I'm ready. Okay, do you have one in mind?
No, any of them I don't like. Any of
Okay,
them.
so let's try and find another word problem. Any particular topic?
Nope, not particularly. I just don't like any of them. No, so the one, was it
Okay.
1.7
Yeah.
last time that
Yeah.
I think I just,
Okay,
Again, my
so
brain
let's say
was
problem 124 on page 205. Excellent question. Let me get my tent ready, just in case, because I think the sun will come up very soon, so I'm gonna have this ready here. Okay, it will interfere. It interferes all the time. Okay. A city commission has proposed 2 tax bills. The first bill requires that a homeowner pay, so the first one, $1,800 plus 3% of the assessed home value in taxes, of the home value. The second tax bill requires taxes of $200 and plus 8% of the same thing, of the assessed home value. What price range of home assessment would make the first bill a better deal? Now, obviously, we should understand that this is a better deal for us. Yes, we have to pay taxes for schools, for students, for all sorts of programs, and we have to pay taxes. That's clear. But we still want to pay, if we can, less. If it's possible to pay less, we will always try to, right? Legally. So when we say the first plan is better, it means better for us. If we say the second better is better, a plan is better, it means better for us. So one more time, what price range of home assessment will make the first bill a better deal? So let's denote the home value by X. Can anyone give us an expression that will present this first situation? Problem 124 on page 205.
1,800.
Very good.
0.03.
Very good. Awesome. So when we talk about, I'm telling you I have in my pocket 2%. It makes no sense. I have to tell you that I have 2% of what you have. So for example, if you have $100 in your pocket and I have 2%, it means that I have $2. So once I'm told 3% of, that is mandatory a product. 3% is 0.03 times the home value. Perfect. That's the first plan. Second plan, can anyone give us the second plan? Anyone else?
200 plus.
Right. 0.08x. Very good. So we want the first plan to be more advantageous for us. And I still see the cell phone under the table. I see it. No matter what you do. If you don't look at me, I know when you're looking down, I see that's the phone. It's very simple. It's not complicated at all. Okay, so the first plan to be more advantageous for us. What should the relationship between these two be? Exactly. Awesome. 0.03x, it must be less than 200 plus 0.08x. Great job. Good. So now let's try and solve this and see what happens. I move 0.08 and I move 1800. You do not have to do it as in one step like I do. Just write your own and then check the answer with me. So negative 0.05x, and it's less than negative 1600. And now x. How do I get x? Divide both sides by negative 0.05. So when I divide by negative 1600, so this is 1600 divided by 0.05. Yes, that's all I needed for you to say. So for which home values, assessed home value, not the market value, but the assessment for the county taxes or state taxes. So what will that be when we divide 1600 by 0.05? So I have 320000, I think, or just 10. Let me check. So I put 2 zeros here. So 3, 2, and 3 zeros. I have 1 zero too much, too many. Any questions for me? So what does this mean? What is the conclusion here? So this is comma and this is. So what is the conclusion here? If the assessed home value is over 32,000, we should be happy with this plan because we pay less. If the assessed home value is less than 32,000, this is the better option for us.
That is where you lost me.
Okay?
Why is
Because this plan was less than this plan in taxes.
Spin on Mark.
So we pay less with this than with that. And when we solved the inequality, we got that the home value has to be over 32,000. It's guaranteed that if it's over 32,000, this amount will be less in money terms than this amount. Better?
Yes.
Perfect. Other questions here? Thank you for the question. It was a very good idea. Okay, we can start chapter 2. Chapter 2 deals with functions. And before our first test, we have to go, as I mentioned, through 5 different sections. And the first section refreshes our memory on a lot of things. First of all, it refreshes our memory on definition of a function. But before I start that, I just want us to look at 3 examples. Here's one. Here's the second one. And here's the third one. These bubbles are sets of numbers. So this is set 1, and this is set 2. Oops, set 2, and the same for all the others. And let's suppose I have just 3 numbers, and I connect them like this. 1, 2, and 3, 4, 9, and 10. In the same way, I connect 3 numbers here. One number, another number, any number you want, put it in if you want to. And here is the third situation. So I created some correspondence. I created correspondence between this set and this set 3 different times. Now I see here that to this value corresponds only 1, in the second set to this one only 1, and to this one only 1. This is what we call a function. To each x value corresponds only 1 y value. Of course, these are all x values from set 1, and these are all y values. I'm sure you remember the 2 names are domain. This set is called the domain, and this set is called, very good, awesome. So now this is a function, and we are going to look at the other 2 examples and see whether these 2 are functions. Also, there is a very important property here that I would like you to, at least you may have had experience with it, maybe not, but I'd like to mention it from now. I don't need it right this moment, but I'd like to mention it. So if I go backwards, if I look as if this is my x and this is my y, can I create a function or not? Going backwards. If this is x, do I go back to only one y? If this is now x, do I go back to only one y? And if this is now x, do I go back to only one y? Because that happens, the function is 1 to 1. It's not just one x corresponds to one y, but also one y, each y corresponds to only one x. So going back and forth, both are functions. So therefore, this is called 1 to 1. Why is it so important to know that a function is 1 to 1? We'll see later in this chapter. Okay, let's go to the second example. What do you think about the second example? Is it a function, first of all? What do you think? To each x, only one y? To each x, only one y? No. I found this value of x that corresponds to two values of y. This is called a relation. It's not a function. And still, the first set is still called domain, and the second set is still called range. But this is not a function. What do you think about the third example?
Yes, it is.
Yes, it is. To each x, only one y. Correct. To each x, only one y. Correct. It doesn't matter if it goes to the same value of y. To each x, only one y. Very good. This is a function. Of course, domain and range. But now my question is this 1 to 1? Talia, can you put that away? But away means away. Okay. So, what do you think? Is this 1 to 1?
No.
It's not 1 to 1 because when we try to go back, if this is x, I don't know where to go back, right? Because it corresponds to two different y values. Not 1 to 1. Very good. Now, I would like us to look at the next few graphs. I'm going to graph something. This is the first one. Here's the second one. Here's the third one. And here's one more. I would like you to tell me whether these represent functions or relations. And how do we do this? Same idea. For each x, only one corresponding y. For this x, I will be reading only one y. For this x, I will be reading only one y. But for this x, I will read two y values. So this is the vertical line test. By the vertical line test, is the first example a function?
Yeah.
Is the second example a function? No. Awesome. Is this a function? Excellent. And is this a function? Perfect. Great job. So we can identify functions from links between sets. We can identify function by looking at the graph and using the vertical line test. And now I have one more step. Let's say I'm going to pick a problem from page 230. Let's say problem, maybe a couple of problems here. Let's start with 14 on page 230. We are given x squared plus y equals 25. We're not given the correspondence. We're not given the graph. We're not asked to graph. You can say, well, let's graph it. No, there is no need. So what we can do is solve for y. Whenever we are given an equation and we're asked, hey, does this represent a function? We will have to look at the y value. Solve for y, in other words. So when we solve for y, what do we get? We get that y equals negative x squared plus 25. And now my question is, when x is, let's say, 0, what is y? How much? Excellent, thank you. When x is 1, how much is y? How much?
26.
So 1 squared, that's how I catch mistakes. 1 squared with minus in front. It's not this, but it's this, which is a totally different story, right? So here you square 1, which is 1, and you multiply by negative 1 outside of the square. So what do we get then? 24. Can I continue forever? How many y values will I get for each x value? Exactly. Since I will always get for each x value only one y value, what do you conclude about this equation? Or if you want this equation, they're the same. What do we conclude? Excellent. Excellent. We will conclude that this is a function because for each x value, we obtained only one corresponding y value. Let's take a look at 18 on the same page, and that says for x equals y squared. When we are given an equation, how do we check whether this represents the equation of a function or not, or a function or not? How do we check? What we need to do?
Solve for y.
We solve for y. Let's solve for y. Let's solve for y. Any suggestions on how to solve for y? That's why we covered all this in chapter. Exactly. Awesome. We have to take the square root from both sides. That's exactly it. So when we take the square root, we remember something crucial, because this is, what type of equation is it? I'm looking for a word. This is a quadratic equation. Since it's quadratic, we are looking for how many solutions? Excellent. Well done. So then y equals? Awesome. Yes, plus or minus square root of 4x. And of course, you can write plus or minus 2 the square root of x. And now, when x is 0, what do we get? Y equals? Perfect. When x is 1, what do we get? Say it again. A plus or minus 2, correct. Is that sufficient to make a conclusion or draw a conclusion? What do we say about 4x equals y squared? Is it a function?
Yes.
So we found x equals 1 that corresponds to two completely different y values. So what do we conclude about this? Very good. Relation. Very good. Is it clear? Do we understand what happened? Or did we understand what happened here? Anything? Any questions? Any questions? Is this clear? Yes? Perfect. Let's move on to evaluating functions. I know this part is a review for you, but I'd like to go over a few important topics. Okay? So, function notation, first of all, is f of x, t of p, p of v, any combination. This is the function name. This is the independent variable or argument. Independent variable also called argument. This is also the y value, the function itself, y, or f of x. They mean the same thing. Now, why do we use both? For simplicity. You will see some situations, it's kind of awkward to say, find y when x is 2. It's much easier to say, find f of 2. So that's the function notation. How do we look at a function? So I'm going to pick a quadratic function, or you do. So pick a quadratic function. Any quadratic function you can give me. Anyone? Any quadratic function. Give me a rational function. Give me anything. Anything. Any function. Just give me any function. Okay? 2x minus 1 over 3x plus 2. What type of function is this? What do you think? What type of function is it? We've solved equations with this, so it must be something that we've seen before. Anyone? Is it linear? Is it a linear equation? Of course not. Is it quadratic? No. Is it absolute value? No. Is it radical? Does it have a radical in it?
No.
No. What does it have in it? Very good, awesome. Rational function. Okay, so I'd like to talk about what it means, because that's the first step, the preliminary step towards evaluating a function. So here's when I look at this function, this is what I see. I don't see this. I see this. Why? Why am I saying that? Or what am I showing you here? I'm just trying to emphasize the fact that if you are asked to find f of 10, what will you do? Everywhere, right? 10, 10, 10. What if I'm asked to find f of x plus h? What will I do now? That's it. I say exactly the same thing. X plus h, both x plus h, and I perform the operations. Please remember this concept. This is a very important concept. Being able to understand what the function is telling us, and if we need to evaluate, we know how to proceed. Okay, ready? So we are given a function, and here it is, number 36, and this is still on page 230, and we're asked to evaluate it. So the function is f of x, x to the third plus 1. I'm sorry, 4x to the third plus 1 over x to the third. And we're asked to find f of 2. We're asked to find f of negative 2. And last but not least, f of negative x. You will see what f of negative x represents later in this chapter, actually. Okay, so what do I see? What is the pattern here? 4 times whatever cubed plus 1 over whatever cubed. So you will write 4 multiplied by 2 cubed plus 1 over 2 cubed. Do we agree with that? We will perform the operations in order of operations. The denominator is 8. The numerator will be 4 multiplied by 8 plus 1. Then we have 32 plus 1, which is 33 divided by 8. At some point in time, we are going to graph these functions. Right now, we do have an ordered pair. Can you tell me which ordered pair we just determined? Which ordered pair did we just determine here? What goes in here? Awesome, that's the x value. What goes in here? Excellent. Thank you, Taylor. Exactly, that's the ordered pair. When x is 2, the y value is 33 over 8. Great job. Okay, in the same way, let's find f of negative 2. Any questions? Please feel free to stop me anytime if you have questions, please. That is never, ever an interruption. F of negative 2. Be very careful now, because this time we have to replace x by a negative quantity, a negative number. Therefore, we have to put it in parentheses. So then 4 multiplied by negative 2 to the third power is awesome, plus 1 divided by negative 8. And this is negative 32 plus 1 over negative 8, which is negative 31 over negative 8, or 31 over 8. Which ordered pair did we just determine? Very good. X is right here inside. That's the x value of the ordered pair. And this is the y value that we just calculated. Great job. See, I can't go over these topics or assume that you remember them, because you may or may not, and then we'll have difficulties later. Okay, last one, we were asked to find f of negative x. I know the pattern. The pattern is the same. That's what I see. This time I plug in everywhere negative x. So I have 4 negative x to the third plus 1 over negative x to the third. Negative x times negative x times negative x is negative x to the third. All I have to do is multiply the numerator and remove the parenthesis. It would be nice to factor out negative 1 at the top. And I get negative 4x cubed minus 1 divided by negative x cubed, because these two will cancel out, because negative over negative is going to be positive. 4x cubed minus 1 over x cubed. I'm not going to ask you what is the ordered pair now, but we can. It's really not something we're going to use in this class, but what would be the ordered pair in this case? And that answer. Good. Okay, so we established that. The next step, I would like to look at a graph in your book and identify the domain and range, several graphs if you like, and read from the graph. So let's look at problem 82 on page 231. And I'll show you the graph, and we'll analyze it together. I like this, this graph. Okay, so let's take a look and identify a few things about this. First of all, is this a function?
Yes.
By the vertical line test, this is the function. I would like to identify its domain. The domain is read on the x-axis. From the leftmost point till the rightmost point where the function exists, right? So here, this is an open point. The point does not exist. So it's between this and this. So can anyone give us because I want to write it at the same time. Can anyone give us the domain? Yes, the domain will be with a parenthesis, -6, comma 0, with a bracket. Do we understand? I know you can see. -6, comma 0, parenthesis, bracket. Can anyone explain why it's a parenthesis and -6? Because it's an open point, it doesn't exist. Awesome, very good. Then I would like to determine the range. The range of this function or any function is measured on the y-axis. From the smallest positive, from the smallest number to the largest number on the y-axis. From -3 till 4. But since that point does not exist, how will I write the range? I will write from -3 to 4. Close at -3. I know you can see. And open at 4. Okay. Next. I know we haven't talked about this, but this is what comes next. And since I have the graph up here, I want to talk about it. Is this function decreasing as x goes from -6 to 0? Is this function decreasing or increasing? Do you see that? As x increases from -6 to 0, the function comes from 4 down to -3, right? It's decreasing. Very good. Does it cross the x-axis?
Yeah.
Yes, it crosses the x-axis. Can you identify this point? Yes, so I'm going to write, first of all, function decreasing. And that's my 6. So f decreasing on -6 to 0. And then you said that what was it? -4, 0? X intercept. Good. Does this function cross the y-axis? Yes. Yes, right here, right? Good. Can anyone give us this ordered pair? Excellent. 0, -3 is the y-intercept. Perfect. Okay. Now I would like to determine f of -2. I want f of -2. I draw a vertical line because -2 is given. I draw a vertical line at -2. I see it crosses the graph at a point, and I will be reading the y value. -2 point, I accept. So f of -2 is -2.3. What is the ordered pair that we read from, please? Perfect. -2, -2.3. One more question. I would like now to determine x such that f of x is 1. I don't have x. I cannot draw a vertical line, but I have y equals 1. So I will be drawing a horizontal line at 1. The horizontal line at 1 crosses the graph in a point, this point, and I will be reading the x value. Whatever you give me, if it's between -4.5 and -5, I accept it. So how much is x? -4.6? Okay. What is the ordered pair? One. -4.5, 1. Any questions about this graph? Any questions about the domain? Anything that you would like to ask about what we just determined? Whether it's increasing or decreasing, whether it has x and y intercepts, reading from the graph when x is given and then when y is given. Are we comfortable with this? Do we need another example? Another example? Which part is not clear? The domain? The domain is from the so see the graph starts here and ends here. So on the x-axis, just imagine this is between -6 and 0, right? So that's why the domain is between -6 and 0. Is that okay? And the range starts from -3. We have to read it on the y-axis, from -3 up to 4. Is that better? Yes. Tim?
The parentheses and the brackets.
Yes. So if it's an open point, I have to use parentheses. If it's a full point, I have to use a bracket.
And then I'm moving a little bit forward. What about the infinity sign?
Very good. The infinities are always open because I don't know what they are.
So they're always,
They are symbols.
always between the parentheses.
They always be parentheses, yes. So here is what I wrote. So for you to copy it down. So the domain is between -6 and 0. The range is between -3 and 4. The function is decreasing on the entire interval. Notice that I did not use any brackets here. It's just a trend. It's decreasing for any x value between -6 and 0, which is the entire domain. -4, 0 is the x-intercept. 0, -3 is the y-intercept. And then we wanted to find f of -2 and then find x values that make f of x 1. Any questions from me here? Any questions? Okay. In that case, I'd like to continue with 2.2, which we already advanced a few minutes ago, by asking you about decreasing, increasing, and the rest. But I do have a few more items here. One very important concept is what it's called. So this is 2.2. Yes, I hear. Yes, please. Sorry.
I have a question.
Yes.
But like, are we gonna have like classwork, like in class?
Yes. 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 You are going to have classwork. As I said, I wish I could just do classwork and not much else, but I won't be able to. This is a different type of class than the previous classes. It's a 3-credit class, and we have tons of work to look at. Yeah. This is what I wish I could do. Just give you classwork and walk around and work with you on different problems, but we will not be able to get to chapter 5. 6, 8, the entire semester, yeah.
By December?
Yeah. Yep. Yep. Very good. So in 2.2, we're talking more about functions. So what happened in the previous class that you had classwork? You did it on the computer, right? Everything was work on the computer.
No.
Was it? What type of work was it?
Honors pre-calc for this.
You took what?
Honors pre-calc for this.
Okay. But then maybe you shouldn't be in this class. I don't want you waste your time. No, not at all. I want you in my class. Why don't we talk about this at the end of the class, because I have a plan. I have to finish this. But I'd be more than happy. Maybe you belong in calculus. That's all I'm saying. It's not that I don't want you in my class. I want everyone to be here in the class. And I would like to hear about how you did the classwork. It's maybe something that will help me and help you. I'd be more than happy to hear about it. Okay, so more with functions. Okay, so let's talk about the difference quotient. Of a function. Difference quotient of a function. You've been taught this in pre-calc. So what is it? Do you remember?
Oh, I don't remember that much.
Oh, okay then.
You gotta start first. Maybe I get a refresher.
Okay. So the difference quotient, first of all, I would like you to understand what it means. I just don't want to just simply throw it at you and say, here's a function, simplify the difference quotient. I would like you to understand what it means. So let's take a look. Here's a graph. And we will find 2 points. We'll use 2 points on this graph. Let's call it P and Q. And if I tell you that the x-coordinate of P is x, what do you think the y-coordinate will be? Talia, what do you think the y-coordinate will be?
Wait, what was the question? I was getting that.
Okay, so this is a function, and we have a point on the graph of f of x. And I say that its x-coordinate is x. What will be the y-coordinate here?
You said the x coordinate is x.
Yes, so this is a point
So
P.
would it be y equals x?
So the x-coordinate is x. I would like to determine the y-coordinate. What could that be?
Would you want?
Correct. Is there, of course. Is there another way of writing it?
X, Y.
Correct, but that's the point. But is there another way of writing this height? Y is correct. But is there another way?
X plus.
No. Is there another way?
That's an x.
F of x, indeed. This is very important. So the coordinates are indeed x and f of x. Perfect. So let's say now that Q is very close to P, and the coordinates will be just x plus a little bit, just a tiny quantity. If this is x, to the right I have x plus h if h is positive. Can anyone now give us the y-coordinate of Q? Give it a shot.
F of x plus.
Of course. Thank you very much. Indeed. So now we have the 2 points. Say it again.
Can you repeat?
Yes. If I plug in x to get this y-coordinate, I have to plug in x plus h to get this coordinate. Any questions? Any questions?
How does the X change to X plus H inside the?
Because Q has the x-coordinate x plus h. I have to plug it in. That's what I have. The x-coordinate of Q is x plus h.
X is way over there.
So x is right here, and this is x plus h. There are 2 different points. This one has the x-coordinate x plus a little bit. This one has just the x-coordinate. So if this is 5, this is 5.2.
Might have been easier if we used different numbers.
I can't. This is what I have to use. Yeah, I cannot. And now let's suppose we are connecting these 2 points with a line. And I would like to determine the slope of line PQ. Can anyone give us the definition of the slope of a line that passes through 2 points?
Rise over run.
Correct. Which means y2 minus y1 over x2 minus x1. Excellent. Great job. So now, can anyone put in for us the coordinates we have? For point P, we have x comma f of x. And for Q, we have x plus h comma f of x plus h. So the slope of PQ, I'm ready now.
X plus 8. No, f of x. Yeah,
Very good. Awesome. Minus.
f of x.
Great job. Over.
Over x plus 8
Perfect.
minus x.
Very good. Indeed. So we created 2 points. Let's summarize and try to understand this information. We created 2 points on a function. They're quite close to each other. As you notice, x of P is x, and Q is not too far from it. It's x plus a little bit, a small quantity. They appear to be very far apart here because I had to zoom in, I had to explain what I'm doing, but they're very close to each other. Q is right here next to it because this is x and this is x plus a little bit. So then we created this, we call it secant line, and we determined its slope. Of course, I'm going to simplify the x with negative x, and the result will be simply f of x plus h minus f of x divided by h. This is what we call the difference quotient. The difference quotient represents the rate of change. It's the rate of, I'm going to write that down for you. It's the rate of change of this function between p and q. Rate of change of function f of x between p and q. Now, we will be given a function. For example, f of x, we can pick from the book. Page 252. Let's say problem 78. X squared minus 5x plus 8. And we are asked to find and simplify the difference quotient. We know what it means now. It says find and simplify the DQ, the difference quotient. It will be given to you. You don't have to memorize it, but we now know what it is. F of x plus h minus f of x divided by h. So we're asked to determine it and then fully simplify it. So let's take a look first of all at what we have and what we don't have. I see three quantities here, three entities if you want. I see this, and I see this. What do I have and what I don't have? From these three entities, what do I have and what I don't have? Give it a shot. What do you think? Excellent. I absolutely have f of x. It's given to us. It's right here. Great job. Anything else?
The other x.
I have h. It's just a tiny number. Small number. I can't do anything to it. So what I don't have is f of x plus h. That I don't have. So let's calculate f of x plus h. We know we talked about how to read the function, and we know how to find it now. Can anyone dictate? Yes.
Would you plug h plus x into all that?
Absolutely. Just dictate and I'll write it. Of course. Thank you. Awesome. Great job.
X plus h squared.
Awesome.
Minus 5, x plus 3
Awesome.
plus 8.
Excellent. That's what we need to expand, fully simplify. And once we have this third piece, then we'll come back to it and simplify it. Right now, we cannot put the pieces together yet. Good. So I have to square first by the order of operations. So let's see, x plus h squared.
X squared plus h squared.
We have an agreement from the first day of classes.
X squared plus
Very good. Plus, good. Minus 5x minus 5h plus 8. Please be careful. Remember, we talked about the binomial squared. This is the third week of classes. Please. Okay. Now we have all three pieces, and let's put them together. So I will continue here. I will replace this by what I just found out that it equals to. X squared plus 2xh plus h squared minus 5x minus 5h and plus 8. Now I have minus. Have to be very careful. I have to distribute a negative 1 to these three terms. That's f of x, and I have to distribute negative 1. Please dictate.
Oh.
Very good.
Plus
Very good.
X
Good.
minus T.
Excellent. Before we continue, yes? Go ahead. Go ahead.
I was gonna ask if the 8 and the 5x is quasar because they're opposites. Or no?
So before we attempt to simplify this, I just want to make sure that you understand that two things have to happen. Every time we determine and simplify the difference quotient for any function, two things must happen. All terms without h from the top must go away. If they don't, we made an error somewhere. Second thing that has to happen, this h from the denominator must go away. The final form may still have an h in it, but not this one. This one must go away. So two things, one more time. When we simplify, all terms without h from the top must go away, must simplify with other terms. Maybe other terms will simplify, that's a bonus. But definitely all terms that do not have h must go away. And at the very end, this h from the denominator must go away as well. Ready? So then,
X squared is
negative x squared with positive x squared,
negative 5x.
negative 5x with positive x,
Negative
and negative 8 with positive 8. So that happened indeed. The remaining terms, they have a common factor. All of them have something in common that I will have to pull out, which is, great job. And what is left in parentheses? So this is classwork. If you pay attention and you answer questions, this is classwork.
2x
2x,
plus
yes,
minus 5.
excellent. That's why we are allowed to simplify a factor of h, and that's why the final answer is this. Well done.